Everyone, this is question number 25th of exercise 6.5, which is given on page number 233. As I told you earlier, whenever you read any question based on maxima minima, make sure while reading the question you should keep an eye to note down few points that what is given, what do we have to maximize or minimize, what do we have to find or prove in the question. Do we have to find anything or do we have to prove anything in the question? So while reading, we'll keep an eye on these points. Show that the word show means you have to prove something. They are not asking you to find, they are asking you to prove. So it means in this question you have to prove something. Show that the semi-vertical angle of cone of maximum volume and given slant height. So these terms are very important. The term given is very important because you have to write what is given. The term maxima and minima is very important because you have to make a note of that also. If I remove this phrase, does it make a sense? I'm reading the question again. Show that the semi-vertical angle of cone is tan inverse root 2. What do we have to show in the question? We have to show that the semi-vertical angle of cones, let this be cone, and in every question you will write the statements in the beginning. Let R be the radius, let H be the height, let L be the slant height, and alpha, which is given in the question. Because they have mentioned the word the semi-vertical, slant height is L is given. So what is given in the question? The slant height. What is given in the question? Slant height is given. Slant height, which is usually you take as L. What do we have to prove? That the semi-vertical angle, so let alpha is the semi-vertical angle, you have to prove that this is tan inverse root 2. Therefore, you have to prove that tan alpha is equals to root 2. So this is the proving part. Of maximum volume, it means you have to maximize the volume. You have to maximize volume of cone. Okay, so you can remove this phrase and read the question to see what do we have to prove. The one which is inside the bracket is the description about the cone, that the cone is of maximum volume, which you have to prove, and the slant height is given, so we have already taken that. Sorry, which we have already taken that. So it is maximum and slant height. All right, let's start with the question now. Now the question states, first of all, what is given? L is given, and the moment you see cone, you can use this equation that L square is equals to R square plus H square. This is pre-knowledge which everyone has. Now you have to maximize the volume of the cone. What is the formula for volume? 1 upon 3 pi R square H. Let this be equation number 2. Nothing else is given. L is given. L is given means L is constant. It means you cannot differentiate with respects to L because that is constant. Now V is having two variables, R as well as H. You can get rid of one variable using equation number 1. So I'm writing the value of R square because I do not want to write H because then I'll get a root. So why should I write in root? So I'm writing the value of R square, that is L square minus H square into H. So V is now pi upon 3 L square H minus H cube. Now my function V is expressed in the term of H only. L is constant, so L is not a problem. It is only V now. Let this be equation number 3 and let me differentiate it now. I can differentiate this with respects to H. So pi upon 3 as it is. L square is constant as it is. Derivative of H is 1. Derivative of H cube will be 3H square. In every question based on maxima minima, you put the first derivative equals to 0. Whenever you equate it equals to 0, you get the critical point, you get the proving point, you get the proof over here. Then you do the second derivative equals, then you find out the second derivative. If the second derivative is greater than 0, you get a minima. If it is less than 0, you get a maxima. You have to maximize in this question. It means you should get this in this question. So I'm just putting this in the cloud and we'll see how does that work. So I'm putting dv upon ds, the first derivative I'm putting equals to 0. So for maxima or minima, this is equals to 0. From here I'll get L square is equals to 3h square. L is equals to plus minus root 3h. Negative is not possible, so I have not taken the negative sign. So L is equals to root 3h. I am getting this equation. Let this equation be equation number 4. I'm not getting, you have to prove in the question tan alpha equals to root 2, which I'm not getting from here at all. In the question, they're talking about alpha. They're talking about tan alpha. So let me somewhere find out that what is tan alpha according to the figure. Tan alpha. I'm drawing the figure here again, just for your understanding. This is alpha, this is R, this is H, and this is L. Tan alpha is perpendicular upon base, right? The side on which we have both the angles, that is the base, right? So my base is H and my perpendicular is R, so it is R upon H. I'm getting this equation, but still I'm not getting the proving part. I am getting L is equals to root 3H and L is constant. So whenever something is given, you can use that equation. So I am using equation number 1 because somewhere I have to find out the value of tan alpha. I have to prove that is equals to R upon H. R and H, I'm not getting any ratio. So I can use equation number 1. My equation 1 says, equation 1 is L square equals to R square plus H square. That is equation 1. I'm using 1 and I'm using 4 and 4. So I'm solving 1 and 4. So my 4 says L square is equals to 3h square. So I'm using these two equations, means 3h square is equals to R square plus h square. So 2h square is equals to R square. So R upon H is equals to root 2. I can put this in equation number 5. What is R upon H? I'm getting R upon H is root 2. So my proving part is done. I have to prove tan alpha is equal to root 2, which is done using equation number 6. I'm putting the value of tan alpha from here to here. So the proving part is done. But I have still not maximized the volume. To maximize, you have to differentiate it again. So d2v upon dh square, you have to do the double derivative. The first derivative was done over here. So it is done in this blue box. The first derivative is done. So I am doing the second derivative now. So second derivative is pi upon 3 is constant as it is. Derivative of L square will be 0 because L is constant, minus 6h. So this is minus 2 pi h, which is less than 0. For any value of h, it will be less than 0. Hence volume is less than 0. It means volume is maximum when tan alpha is equals to root 2 or alpha equals to tan inverse root 2. So question was not difficult, it was quite simple, and such questions they can ask you. In this particular question, they have asked you the value of tan alpha. They can ask you cos alpha. They can ask you sec alpha, cos alpha. This is the way they are going to change the questions. All right, bye-bye. Thank you.